All right, here's the circle puzzle. So if segment DF is a diameter and segment OF is 10, then segment DO must also be 10. Segment OF and DO are radii and are equal. Therefore, the following segments must also be 10. OG, OH, OB, and OA. So look, all of these, we know CA is a diameter, DF is a diameter, and let's see, what was 10? OF. OF is 10, and that's a radius. So all of these radii are going to be 10, okay? So anything that's a radius will be 10. Triangle AOB is an equilateral triangle. That's this triangle here, AOB. So in any equilateral triangle, the sides are equal, 10, 10, and we were given this as 10. All these sides are equal, so those measures are going to be 60, okay? 60 in every angle of an equilateral triangle. All right, so since we know that, this part here is a semicircle. This part here is a semicircle. And we know now that this is 60. So a semicircle is 180 degrees. So 180 minus 60 is 120. And then these are going to be equal. We know that those are equal because they're congruent. See, it says these angles are congruent. So we know that those are equal. So if this is a semicircle, we do 180 minus 60, and then that gives us 120, and 120 divided by 2 is 60, so each of these is going to be 60 as well. All right, so we know that the angle of the triangle is 60. Oh yeah, if this is 60, then all the arcs that match these angles are going to be 60, okay? And I think you probably know that. So all of those arcs are going to be 60. Okay, so anything like that, all the arcs, you just match them to the angles. So, okay, we'll get there in a second. All right, now segment CA, where's segment CA? All right, segment CA must be 20 because we know the radius is 10 and the diameter is 2r, or 2 times the radius. So 2 times 10 is 20. So we know that's got to be 20. The measure of arc ADB. The measure of arc ADB. Okay, that's this black line that I've drawn here. All right, that's going to be, a circle is 360 degrees. So if we take all this piece, and this is 60, so we can do 360 minus 60 and get 300. All right, arc FDB. Arc FDB is the same way. So arc FDB is the same way because we have 60 left out. 300 minus 60 is 300. Okay, angle GIC. Okay, angle GIC, that has to be 90 also, because if you have, we know that this is perpendicular because it's a right angle, so all these angles are going to be right angles. And if a radius bisects a chord, or if a radius is perpendicular to a chord, it bisects it. And so we know that this is perpendicular because this is a right angle. It also bisects it. So here, so we know that GH, or GI and IH will be each be equal. We already have 6, so we know that's 6. GH is going to be 12 because 6 plus 6 is 12. And then this angle is a right angle. All these angles are right angles because this is perpendicular, because we're given that this is 90 degrees or a right angle. Okay, where are we now? Arc DF. Did we do that yet? Arc DF is a semicircle. Okay. Arc DF is a semicircle, so we can figure out angle COD the same way that we've done before. If DF is a semicircle, we're going to figure out angle COD that same way. Hold on just a second. Oh wait, angle COO, the semicircle of arc CA, I'm sorry. CA is a semicircle, okay? So we are going to figure out CF that same way. We were given 60 and 60. If the semicircle here is 180, 180 minus 60 is also going to be 60. So this whole thing is 60. Your arc here is 60. All right, then we have a semicircle right here. If this is 60, this section here has to be 120, and this arc is also going to be 120. Okay, and then you use the Pythagorean, wait, do we need, yeah, we do need Pythagorean theorem, I think, to figure out what this section is. So you use Pythagorean theorem with this triangle piece here, Pythagorean theorem. So you would do 10 squared equals 6 squared plus x squared, and you should get that this is 8. We know that this is a radius, and the radius equals 10, so you would do 10 minus 8 and get this little piece here, which is 2. Okay, so I think that covers everything about how to figure out this puzzle. So there you go.